Hi class, welcome to this class of Introduction to Multimedia Technology and Application. Our first chapter is on the theory of image. All the material on PowerPoint of this course will be on theory only, and the real work of the class, that is your hands-on on developing your artwork, will be guided by video on the respective hands-on. By the end of this chapter on image theory, you are expected to understand the basic theory of digital image. The content of this chapter is some definition first, and then we talk about color models, then what is alpha channel, then about image size and image format. Let us go through a few simple definitions regarding image. The first is definitions about the type of images. There are two types of image: raster image and vector image. For our class, we will cover on the raster images. But let us get some idea about what is vector image. Vector image is the piece-by-piece definition of drawing. Let's say you have a drawing that consists of a circle and also rectangle, triangle, and so on. You define the image by telling what is the length of the rectangle, the width, the radius of the circle that you have in your drawing, and the triangle, what are the angles of the edges, and so on. So that is what we call vector image, because defining the pieces of this drawing is actually defining vectors of the drawing. This kind of image is resolution independent, which means it does not degrade if we enlarge it. If you have experience enlarging certain image, you will see that the image is going to be deteriorated if you enlarge too much, if you exceed the resolution of the image. You will actually see the pixels of the image. Later we will see what's the meaning of pixel. So the example of this type of image, that is vector image, is CGM, computer graphics module, SVG, scalable vector graphics, and SVG is actually quite popular in Wikipedia. The one that we are going to work in our class is raster image. It is actually a 2D matrix of pixel. There will be pixels arranged horizontally and then repeated vertically. That will make up the image that we want. Because of that, it is resolution dependent. If we enlarge the image too much until the pixel shows up, that is what you call the artifact of the image. So in that case, we say that it is resolution dependent. Next, let us define dimension with regards to image. Digital image can also be viewed as electronic signals arranged in two-dimensional structure, as we said just now. For the definition of raster image, and due to this two-dimensional structure, we have two types of dimension, the width and the height. Width is the number of pixels in horizontal direction, and height is the number of pixels in vertical direction. So this is what we call the dimension of an image. Then now it comes to resolution. Resolution is the number of pixels per dimension. We can also say the number of dots. Pixels normally is for display devices. Dots is for printed images or printing devices. So the number of pixels, in next slides we will see what is the meaning of pixel. Is actually dots also. The number of pixels or dots per inch is what we call the resolution. If we have more pixels or more dots per inch, the resolution is higher, and because of that, the image will look smoother. Otherwise, the pixel of dots will be too big and you can see the jagged boundary of the objects in the image. And normally the vertical and horizontal resolutions are the same for image. Next is the definition of pixel. Pixel is the smallest element that represents the color value at certain coordinate in image. It can also be the unit of the dimension. Just now we say that a raster image is a 2D arrangement of pixel. So these are the pixel, the smallest element in the image. And what the pixel keeps in its place is the color of the image at that location. So sort of we can tell at, let's say, 5 pixels to the right, and let's say 25 pixels up, the color is, let's say, gray, and then 20 pixels up it is yellow, and so on. So pixel is what defines the color at certain location in the image. So as you can see, this is the image. If we enlarge it too large, we can see the individual pixel. This is what we mean by degradation of over enlarging, and this is also what we mean by resolution dependent of raster images. Next is aspect ratio. Aspect ratio is the ratio between width and height of an image. Example, if image size is 10,000 pixel width and 500 pixel height, then the ratio is 2 to 1. During editing, it is good to keep aspect ratio the same. If you enlarge or shrink your image so that the resulting image is not distorted. Circles may look like ellipse if it is distorted. For example, let's say this is original image. The size is 340 by 340, so the aspect ratio is 1 to 1. If we enlarge it too much, it becomes 680 by 340. We stretch it too much horizontally. Now the aspect ratio is 2 to 1. So the basketball image now looks like an ellipse instead of a circle in the original image.